Hi everyone and welcome to the AWS Nordics Office Hours. I am Gunnar Grosch, and as you know, we like to get together here every week, every Monday, to talk about an AWS topic with an exciting guest. And you'll get to ask your questions on the topic, which then me and my guest will try to answer as best as we can. So simple enough. And this week, the topic of the show is modern application development with persistent storage. And to help us learn everything there is to know about that topic, I am joined by Will Ochandrina. Welcome, Will.
Thanks for having me.
So, who is Will Ochandrina and what do you do at AWS?
So, I am a product manager with the Amazon Elastic File System team. My focus is modern applications and integrations with other AWS services. So as part of that, I've been involved with the launch of integrations between Elastic File System and container services like Elastic Container Service, Elastic Kubernetes Service, AWS Lambda, and a few others.
All right. So as you know, the format of the show is that we'll talk about this topic and you as a viewer can add your questions along the way. And don't worry if we don't get your questions straight away. We'll try to pick them up where it is relevant. So, Will, let's start with the topic of the show, then modern application development. What do you see as modern application development?
So modern application development, from my perspective, is any time that you create an application using modern techniques and services. So this could include creating applications in containers or serverless in order to have it be agile, scale up, scale down. It could be using continuous development, continuous integration to deliver applications faster. Anytime you're using these new techniques in order to make your applications do more for you.
And then we have the persistent storage part. And you already mentioned that you are a product manager for Amazon EFS. So right. I'm guessing that Amazon EFS is the way to do persistent storage.
A lot of times, yes. So what we're seeing is a lot of customers are taking existing applications and modernizing them. So taking something that might have been running on-prem, might have been running in EC2 instances for a while. And there are a lot of opportunities to modernize these applications, put them in containers, and launch them on container services. So you have less of a operations task on those applications so that they scale easier. A lot of these applications already rely on persistent storage as part of what they're doing. They may be sharing data between multiple instances of their application. A persistent storage layer might be how they share data with other applications. So as you modernize these applications, often you want to modernize your storage as part of that, and that's where EFS comes into play.
So then let's go there. What is Amazon EFS?
Sure.
Tell us the brief story about EFS.
Yeah, so as the name suggests, it's a file system. Also, as the name suggests, it's an elastic one. So what we mean by that is you can create a file system, and that file system will grow and shrink based on how much data you're storing at any given time. So you don't have to worry about sizing it or scaling it with your application. We take care of all of that. As part of being a file system, it means it's a shared file system, which means this is the kind of thing where you can write data to it and then read it not only from the instance or container or function that you are in, but also from another or 10 more or 100 more or thousands more other parallel instances or invocations or something. So it's a elastic shared file system. Just a couple of more attributes of it I'll cover, and I think we'll get to other ones later. It is a regional service. By default, you can also create a one-zone version of that. But in its regional form, what happens is anytime you write data to EFS, we persist that data across multiple availability zones in your region, which means it's durable. So you can rest assured that you have high durability on that data. But the interesting thing for modern apps means that you can read that data from whatever availability zone that you're in. So if you have an application that either fails over between availability zones or needs to be active across multiple availability zones, you can do that, and EFS is just the glue that holds that application together.
And I think partly you answered it there, but why would someone use EFS instead of, say, EBS or S3?
Yeah, so the two key considerations there are API and degree to which you want to share that data. So first with EBS is a single attach, in most cases, single attach block storage device. So it works well for cases where you have a piece of storage that is specific to a specific instance of an application, specific container or EC2 instance. But if you need to share between multiple, then you need a shared file system that kind of pushes you to EFS. Another reason you might choose EFS over EBS is because of the regional nature that I just mentioned. If you want anything that can fail over from one availability zone to the other or operate across availability zones. A lot of these properties are also shared with S3, the regional nature, the shared nature. So when it comes to S3 versus EFS, really just comes down to the API that you want to speak. So if you're modernizing an existing application that already opens files, reads and writes files, closes files, migrating to a file system is much easier than rewriting to a object interface. But if you have an application that already speaks an object API, or that's just the way that you want your application to deal with data, S3 might be your choice.
And I think a lot of builders are familiar with EFS, perhaps by using it with EC2 instances. But during the last year, there has been some news in regards to EFS and integration with other services, mainly container services. So can you tell me a bit about what was released last year?
Sure. Yeah. So the first thing we released last year was an integration between EFS and Elastic Container Service, including Fargate. So up until this time, customers were able to do a little bit of under the hood hackery and get EFS file systems attached to ECS instances and then pass them through to containers and things like that. But it wasn't a seamless experience, and it didn't work with Fargate. So what we saw was a lot of customers were doing this, and there was a lot of demand for us to make it a native integration, and that's exactly what we did. As part of doing that, we also launched some new features on EFS, namely IAM authorization and access points, which I won't get into now. I'll talk through them in the demo. But after we launched ECS, we went ahead and launched a integration with EKS, Elastic Kubernetes Service, by way of a CSI driver. So that's the standard way that all storage services interact with Kubernetes. So we didn't want to be an exception there. We created an EFS CSI driver, moved it from alpha, beta, GA, recently added dynamic provisioning, and that's the way that you can interact with EKS or EFS from your EKS pods. And last but not least, we launched integration with AWS Lambda. Here, a lot of customers wanted a way to deal with shared data or persistent data from their Lambda functions, so we integrated it natively into there too.
So I suppose that those new integrations with both the container services and with AWS Lambda opens up a whole new set of use cases for EFS.
Certainly.
Yes. So talking about that then, I saw recently a launch around dynamic provisioning for the EFS CSI driver. What is that?
Sure. So when you're using Kubernetes, there are a lot of Kubernetes specific concepts at play. So when you first set up your Kubernetes cluster and you want to set up storage, there's a couple of objects that a storage administrator or someone acting in that role would have to create. First, there would be a storage class setup, which is the thing that developers see and are able to request. So an example of a storage class could be this is high performance block storage, or this could be high performance file storage, or this could be cost optimized file storage. So it's kind of at that layer. And then within each storage class, there would actually be persistent volumes, which are instances of that storage class that are actually backed by some backend storage. So when we originally released the driver, we supported a mode called static provisioning, which meant that administrators would first create a storage class, then they would create persistent volumes that were backed by EFS file systems. And by creating those, they make a kind of a pool of available storage volumes that then when a developer comes along and takes out a persistent volume claim, they get associated with. But what customers were telling us was there was a lot of work set up in initially provisioning their cluster, in creating those persistent volumes, and they wanted the Kubernetes CSI driver to do that for them. And that's what dynamic provisioning does. So with dynamic provisioning, you create a storage class still that points to a EFS file system. And then when users create PVCs, instead of being allocated something that you already had to create, the driver will go to the file system, create an access point in that file system, map that to a dynamically created persistent volume, and then give it to the user. So you've taken away a lot of the provisioning steps needed when getting this up and running.
All right. And frequent watchers of this show knows that I am a huge fan of serverless and using AWS Lambda. And I was very excited to see the launch last year for EFS support for AWS Lambda. Can you tell me a bit about how you're seeing that customers are using EFS with AWS Lambda?
Sure. Yeah, so the use cases for Lambda kind of fall in one of two categories. One is several use cases simply just wanted more persistent storage. So before this launch happened, users that were reading and writing files from their Lambda functions were limited to the amount of temp space that you had in your function. So it was 512 megabytes. So there were a lot of examples where you were maybe doing an ETL pipeline, and as part of that pipeline, you needed to read and write large files, but those files might be 600 megabytes, 700 gigabytes, something like that. And there was just no place to put it in your working space. So what a lot of customers are doing with those sort of use cases is simply attaching a EFS file system to their function and letting that be the space where their applications read and write data from. That way they've an unlimited amount of temp space in their applications. Another category of use cases we call our reference data use cases, which are cases where you have some bit of data that needs to be shared between all of the invocations of your Lambda function, which ordinarily wouldn't see the same data. They wouldn't even see the same temp data, but you want them to all operate as if they are using this shared view of data. So the most common example of this that we're seeing is machine learning inference. So with ML inference use cases, first thing you want to do is have a shared set of libraries on all of your invocations of your Lambda. This can be MXNet, TensorFlow, something like that. And then you have a shared model file. And that model file is the thing that you are using to inference off of. So this could be an image classification model, a text classification model. And every time your Lambda function gets called, invocations spout up and they consult with that model and give some results. So the nice part about doing ML inference with Lambda is the fact that it scales up and down elastically, and you only pay, really you pay for each inference that you do.
Right.
But in that case, you need a place to put that model file in a way that's shared among all of the invocations that come up. And it turns out EFS is a really easy way of doing that. So you put your model file in EFS, you reference it from your application, and then it doesn't matter how many times your function is invoked, that model file is used. And by the way, it makes it really easy to swap out that model file every time you retrain your model, and it's instantly picked up by all of the invocations of that function. So it's in production immediately.
And now with the added container support for AWS Lambda, I suppose it also opens even more use cases with EFS. You're able to have bigger Lambda functions, but still make use of that persistent storage as well.
Yeah, good point. So in the example I just gave, where you might have previously had both your libraries and your model file on EFS, you probably now want to put your libraries inside your container definitions, since you want them closer to your function. But the model file you'd be swapping out more often, so it makes sense to decouple that.
Cool. So there is a question in the chat around performance with EFS compared to EBS. Is that something you can talk briefly about?
Sure. So there are a lot of different performance attributes of both of these services, namely throughput, IOPS, latency. So in both cases, so with throughput and IOPS between EBS and EFS, they're both comparable and they're both configurable. So you can, out of the box, an EFS file system can go up to 35,000 read IOPS, 7K write IOPS. You can configure up to a gigabyte per second of throughput, 3 gigabytes per second of read throughput. So it scales pretty high in these regards, and it's a similar order of magnitude to what you would get with EBS. Now, latency is the third attribute. So latency is every time you do an operation, how long does it take for that operation to return from the storage? And there's latency differences between the two services, primarily just because of the way that they're built. So EBS is a service where all of your data is held within a single availability zone. With EFS, we write it to multiple availability zones, which just means more transactions going on behind the scenes. So EFS does low single-digit millisecond latencies. EBS does sub-millisecond latencies for most operations. So a lot of the time, this doesn't matter. Like if you're reading and writing big files, you aren't going to notice that latency. But if you have a relational database use case where you're doing frequent transactions with small IOs, that might be a case where EBS is a better choice simply because of that attribute.
Right. So we are 16 minutes into the show. If you just joined us, this is the AWS Nordics Office Hours. I am joined by Will, who's a product manager at Amazon EFS team. And we're talking about modern application development with persistent storage. And 17 minutes in, and we haven't seen either the console or a CLI yet. So I think it's time, Will, to show the people a demo of this.
All right.
Let me bring up your screen. There's the console. So now we can check that.
Great. So what we're going to walk through several different aspects of the console here and ultimately show what it looks like to put a Lambda application on top of a EFS file system. And the inspiration for this one is there was a blog recently of a customer that implemented a search engine using Lambda on EFS, and I thought that was pretty cool. I didn't want to create an entire search engine myself, but I created a prototype of a very simple search engine to illustrate these components. So that's what I'm going to walk through.
All right. Yep, go ahead.
So the first thing I'm going to do is just walk through the file system creation. I have one already, but we're going to pretend we're creating a new one. Whoop, clicking on the wrong one. There we go. Okay, so we have streamlined our console recently. So for most cases, creating a file system is as simple as creating that orange button and then clicking the orange button again. But we can walk through some of these choices here. So first, I could name it. I could choose which VPC I want to put it in case I have multiple VPCs. In this case, I just want my file system to be available from my default VPC. And I mentioned earlier that we support both regional file systems where data is written to multiple availability zones. We also have a one zone variant where all data is held within a single availability zone. And in case you're wondering why anyone would choose a one zone file system when regional is available, it comes down primarily to cost. A one zone file system is 47% lower price than the regional offering. So for a lot of cases where you're developing applications or have kind of dev test environments or something, one zone might be a good choice. But for this case, I'm going to leave it as the default regional and click create. Now what's going to happen behind the scenes when I create that file system is, of course, it's going to create it with the various defaults. So performance mode of general purpose. I'll talk more at the end about performance considerations for throughput mode, performance mode, but it chooses intelligent defaults for those. Lifecycle policy, none. It's interesting. And it's a regional file system. But the thing that's going to be happening is behind the scenes, it's going to be creating these things called mount targets. Mount targets are think of them as the windows into your file system, or the doors into your file system from each availability zone that you're in. So this is, we can see here that I'm in US East 1. There's a lot of availability zones there. So I'm going to have 6 mount targets. So if I am a application running in this availability zone, this is the mount target I'm going to use. If I'm in this availability zone, this is the mount target that I'm going to use. The data is the same behind all of them because the file system itself is regional. These are just the ways that you get into it from each availability zone. So the next thing I want to highlight, now that I have my file system, we created this new concept for modern applications called access points. So now's a good time to explain what these are. Access points are application-specific entry points into your file system. And the main thing that access points do is they simplify the process of dealing with identity of your application in your file system. So let's create one and go through what some of these fields are. So again, I name it. First thing that I'll show you is Posix User. So whenever you're dealing with a shared file system, all of the permissions of which files and directories you're allowed to access come down to who you are. So the user ID and group ID that you're operating as, and the ownership of files and directories to those group IDs. So I'll show an example later, but assume that a file is owned by user 1000, group 1000, and the mode bits or the permission bits on that file say that the user can read and write it, the group can read only, and everyone else cannot access that file at all. In that case, it's important then that all of the applications coming in have the correct user ID and group ID in order to get the permissions that they need on that file. And that's what access points do. Now, in a world without access points, what tends to happen is applications mount file systems, and then they tell the file system what user ID and group ID that they are. So in most cases, EFS will trust the user ID and group ID coming from the application, which in many cases is valid. Like if you have a Linux machine that's administered, people have to log into it in order to take their credentials and things like that. You can trust it. Yeah. But in the case of a container or a Lambda function, the ID that that application is running as is often determined at build time. So if somebody built a Nginx container at some other company and you're just spawning that, you may not know what it's going to come up as. A lot of these just come up as root for convenience, and root users can read and write whatever they want. So what access points do is allow you to pass that application through a filter in some sense and rewrite their user ID and group ID to what you want that application to be coming through as, not what the application says it's coming through as. So like in this case, I will say that the user ID and group ID of this application is 1000, 1000. So this is the same as like an EC2 user on an EC2, on a new EC2 instance. The next thing I'm going to do is define what root directory I want to be put in. So if you're sharing a file system between multiple applications, you may not want all those applications to see all the data. You may want them to come in and just see a subtree of the overall file system. And this makes it easy to do that. So here I can just say my AP. So now any user that comes in through this access point is going to be routed to this path, not the root of the file system. And if it doesn't already exist, I can say that I would like EFS to create it for me by just putting in what I want the permissions to be on it. So I see here that I want it to be owned by 1000, 1000. So in most cases, you want these to match because you'll want to read your own data. And I'll say 750, which is I'm allowed to read and write. Any one of my groups allowed to read, and everyone else has no access. I can create that. I now have an access point. So I'll show you more about that connecting in just a little bit.
Let me just jump in with a question in
Please.
the meantime here. So there's a question by Swapnil. Why EFS. Why is that a better choice than S3 for this type of application?
Yeah, so in a lot of cases, it makes sense to have a file interface instead of an object interface within your Lambda function. So obvious example of that is the wider temp space. So if you were working on files in temp space already, you're already using a file interface. So EFS is just a bigger file interface for that.
Right.
Other examples where it may make sense is if you're working on data where the files are large and you need to read and write small parts of those, it's really easy to do that using a file interface because you can seek to the part of the file you want, read it, maybe change it, and then move on. Whereas with S3, you might be doing whole object gets and puts. Another example is with S3 in a lot of cases, it may be the place where you actually keep your data long term. But if you're going to operate it in Lambda, you would need to download it first. And then it's a question of where do I download it to if there's only 512 megabytes of temp space. So really it comes down to how you need to operate on that data and what the access patterns are. Some of them are better suited for a file. And in the demo that I'll show in a little bit, I'll walk through how the caching that happens under the hood for EFS makes it snappier than if you were downloading files from or downloading objects from S3 every time.
All right, great.
Any other questions before we get into the Lambda side?
No more questions right now, no.
Wonderful.
A comment, by the way, by Tata that this is the exact use case he had to deal with. Dockerized app with shell access, and they were getting to write onto EFS with root. So,
thanks for sharing.
Yeah.
Exactly what we were going for. Okay, so I have a file system, I have an access point. Let's walk through creating the Lambda function. Maybe I'll just do this in a, similar to the other one, I'll create a new one so that you can see the configuration, and then we'll go into the one that I already built. So we're going to create a new Lambda function. Many of you may be familiar with this. Python. So the thing that you will want to do if you are connecting your Lambda function to EFS is put that Lambda function in a VPC. And that's because EFS is available from within your VPC. It's not a public resource like S3 or other things. So you want to make sure that you get the networks all set up. So it's pretty easy in this case. You just select the same VPC that you created your file system in. You select the subnets that you want to run in here. I can just choose all of them because I know I have a mount target in each of these. So as Lambda load balances my invocations across these subnets, each one will just hit the mount target in the respective subnet. And then for security groups, easy one to do here is default. That's the default security group we put on your file system when it's created. So if you pick the same one here, you'll know that your Lambda function can talk to your file system because the security groups all match up. And we'll create my function. If this takes too long, I'll just switch over. There we go. Okay, so the next thing you would want to do is go into configuration. There is a configuration option for file systems. So I could add file system. It knows all about them. This is the one that we just created. With Lambda, you have to use an access point. The reason you have to use an access point is Lambda does not, in any other place, expose to you what user ID and group ID your application is running as. That's just not a thing that serverless developers typically think about. So by putting an access point on it, that's where the identity comes from in all cases. So by going with this one, we'll see that my user ID and group ID are going to be 1,000. I'm going to have a path so you see what's happening here. And then you have to say where in your function you're going to mount this to. So if I say mount EFS, that means that any file that I write within this path is going to be going to EFS. That's really all you have to do to set that up. So let me jump over to my actual application, and we'll show how the code can talk to EFS. So again, this is my the simplest possible prototype of a search engine on EFS. So the idea here is there is a search file stored in EFS. So here's where I'm mounting my file system to. This is the file within that path that contains the thing that it contains the text that I'm going to be searching against. So I'll just give an example of how I'm calling this API. So I'm sending a post to this. So there's an API gateway and stuff like that that's in between, that's exposing this function to the world. But I call post on that, and I'm just sending it a word, and it's telling me true or false whether that word is in the file system. So here, so I'm just echoing random strings in here. This was true before, so it found fox in my file. I'm going to change my file to cat, and now it's false. So one of the cool things that demonstrates is how quickly Lambda picks up on any changes to the underlying file system. So this could have been me switching out the ML model file under the hood, and now that's just the one used by all of the invocations of my application. So this is super simple to, excuse me, get up and running. So obviously I'm reading the request to see what search string was coming in. And then when it comes to reading my file, it's the way you would read any file from any application. So I'm just opening the file and then reading it into a variable, and then that's it. So I'm just comparing the search string to the file. So if search string in contents, then it's found. And really that's it. That's the super simple version of this. So.
And I think that's really interesting to see there the difference compared to, for instance, using S3, where you would have to import the SDK to be able to then reach S3 to fetch data and to do something with that data. In this case, you're purely using, you're importing OS to be able to do the file, reach the file system and to open that file. So really cool.
And on a similar note, with S3, you would also want to build in logic for continuously validating that the S3 object hasn't changed. So you could come up, you could look at the modify time or something like that of the object. If the modify time is different, then re-download the object and stuff like that. Like it's certainly possible to do, but that's going to be natively what's happening under the hood with EFS. So a little bit of what's happening behind the scenes here. So every time I do this, it's not necessarily reading the file from EFS over the network. There is caching happening under the hood on your Lambda invocation. So many of you that have worked with Lambda know that there are warm start invocations and cold start invocations. And that has to do with whether Lambda is allocating a new container behind the scenes to run your Lambda function in, or whether it's reusing a existing container for that invocation. Now, there is a shared cache at that container level. So the first time I call my function, it's going to come up, it's going to read the file over the network, hold it in that cache, execute the function, whatever. And then the next time I call that function, it's going to be a warm start invocation in that same container. The file is already in that cache. So behind the scenes, all it's going to do is validate that file can be read out of cache by doing what we call a stat call to EFS. So it's a super lightweight call that says, has this file changed? The answer is no, so it reads that file from cache. So in my case, the file is only a couple of K anyway. So it doesn't matter if I'm pulling it over the network, but imagine if you had a 500 megabyte model file. During your warm start, that might take a few seconds to pull all of the 500 megabytes over the network into your Lambda container. But then all of the subsequent warm starts that happen in that container would be read just out of cache, so it would be instant. We'll talk more about throughput later, but really the way to think about throughput between your file system and your Lambda function, it's more of a function of how quickly your warm starts are happening than how many invocations you're happening. So if you have a sudden burst of load and you need to warm start another 15 containers or something like that, that's where the downloads are going to come from. But then once they're warm, you'll see the load on EFS go back down.
So how does that caching work? And for instance, if there are changes to the file system for files, how does that get invalidated?
Yeah, so the cache is actually just a vanilla Linux page cache
Right.
that's happening under the hood. So it's the same thing that would be happening if you're using a container or using a EC2 instance. It's just a Lambda in this case. And the way that it's getting continuously revalidated is the kernel underneath your Lambda function is going to be continuously doing that stat call to EFS and getting information about whether the file had changed. If the file does change, it clears the cache, re-downloads, and keeps moving. But if it validates that the file has not changed, then it just keeps using its cache version.
All right, so it will get invalidated as soon as the file changes then.
Yep, and you don't have to build it into your code, which is...
No, exactly. Less things to own. That's always the goal with what we're building. There's a question around triggering Lambdas. And I know we can't use EFS as a Lambda trigger. Is there a way to that you know of or have seen to trigger Lambdas based on changes on EFS?
I've seen, so we don't yet support it as a native source where we'll catch everything, send it as events, like S3 bucket notifications or something like that work. Now, I have seen cases where customers implement this themselves. So one example would be if you have two Lambda functions that are passing data between themselves. So one stages in an ETL pipeline. So one function writes a file, does some operations on that file, and then wants to trigger another one. You could do a decoupled notification where you just SNS or any other Kinesis, whatever notification source that you want to do, that would let the other function know that it's ready to run. Another one that I've seen customers do is there is a Linux-based notification tool that I'm blanking on the name of right now, but you can have it watch a directory and it will emit events when that directory changes. Now, the caveat here is it only works if you are running that on the host that is changing the data. So if you have a single host that is putting files in the file system and you want to notify things downstream, if you're running a daemon that uses, I forget what the file watcher daemon is, but that could be a way of doing this as well. But again, the caveat is it won't pick up changes that anyone else makes.
All right. Yeah. So the
I
question.
notify. Thank you.
All right. There we go. From the person asking the question. So that's good. All right. So then, if you just joined us, this is the AWS Nordics Office Hours. I'm joined by Will from Amazon EFS team, and we're talking about modern application development with persistent storage. And Will has just shown us his search engine, which is gonna take over the internet soon, I suppose, built on AWS Lambda and Amazon EFS.
So what I figured I would show next is to really illustrate the point of access points. So we see that we have this search.txt. So I'll pull up so here I have an EC2 instance that has mounted that same file system. So if I do this, I'll see that I have mounted my file system to this path right here. I'm inside the directory of my access point, Lambda demo AP, and then I have this search file. So I'm able to interact with the same data that my Lambda is interacting with. So this makes it easy to stage data. You see earlier, I just echoed a string into that. Now, we can see here that the permissions on that file are owned by EC2 user, user 1000, user and group, and that it's the permissions that I mentioned earlier. So the user, EC2 user, can read, write, execute. The group can read it, and no one else can access it. So if I come from a different access point, I think this is where I have it. Well, let's try it. Good, permission denied. So let me show you the access point that I'm coming through so that you can see what's happening here. This is my demo file system access point. So I created another access point called other AP with user 2000 group 2000. So I have mounted using this access point, same file system, and I can see that the file exists because I have directory read permission, but I don't have the file read permission because we just looked at it. Now, to illustrate the point about not being able to be whoever I say I am. So ordinarily, if I wasn't going through an access point, I could just simply do sudo cat search. And instead of doing this read operation as user 1000, who I am on the Linux host, they would try to do it as root or user ID 0. But even though now I'm sending a root operation to EFS, it's passing through that access point, getting remapped back to 2000 just as it was before. I still don't have permission. So this is a way of making sure that your applications, even if they say they're root, aren't root, and they have the permissions that they want.
That's cool. And this was done now on EC2 instances as an example, but this is, of course, the way you would do it using AWS Lambda or containers as well. So set up different access points that are then able to have different permissions based on what the action they're are intended to do.
And an example of that, if we look at the ML inference example, you may have one function or maybe a container or something that is training that model. And at the end of training, you'll want it to be able to write to that location in order to update the model. But you don't necessarily want your Lambda function that's doing the inference to be able to write to that. So you can have two access points, one that can write the model file, the other that can read it, with two different applications.
That's really cool.
One other cool thing that you may find if you like to browse our AWS samples is we've recently published a serverless file manager to that. So the idea here is if you have a file system and you want a web-based way to list files, read files, write files, you can use this, and it's super easy to get set up. I'll go to the when you deploy the stack. So you go to the GitHub repo, you deploy the stack. It'll give you an interface to hit, and it'll list your file systems and tell you whether the file manager is already managing them or not. And then in this case, I've already decided to manage it. Excuse me. So I'll click in here, and now I can navigate it. I can upload files, download files. I should have been ready. I meant to put files in this ahead of time so you could see me downloading them, but you can believe me that it works. But this is a cool thing for two reasons. One is it's a good technology proof of concept of an application reading and writing data from EFS. It does a lot of handy things like multi-part upload and download so that you can actually do it with real files. But the other thing is, in a lot of cases, if you're only accessing your file system from Lambda, you may not know it's in your file system. I have an EC2 instance, so I'm able to do like an LS on my file system and see what's in it. But if you didn't have this EC2 instance, how would you know? And this is a good way of doing that as well. So we'll post it. Oh, I see you already posted a link.
I posted a link, yeah. I think that's a great point. I know a lot of serverless developers who's never spun up an EC2 instance. So,
or maybe you're not allowed to. Maybe like
no, exactly.
Inference or something like that.
There was a question around access points and pricing. Can you have as many access points as you are allowed to, or does it affect the pricing?
Access points come with no additional charge. So with EFS, pricing is based on how much data you're storing, primarily optionally based on how much provision throughput that you're configuring. So you can create as many access points as you want. It doesn't change your price. You can, just in terms of limits, you can create up to 120 access points per file system. So like if you're in one way of looking at that is you can have 120 applications hanging off a single file system where they either share the data with each other or each one has their own view.
Right, cool. So you mentioned now provision throughput. So is this a good segue to talking a bit about? Let's
do that. Yeah, so let's jump into the monitoring piece. So it's always a good practice to monitor your file system usage. And that could be in terms of throughput, IOPS, storage. So the two best things to look at from this monitoring tab of your file system is throughput utilization and %IO limit. Both of these show what percentage of your total throughput and IOPS limit that you are coming to with the IO that you're doing. So with my tiny file and a few IOs, you can see that I have a minuscule amount of IOPS, and therefore I'm nowhere close to my %IO limit. But this is something where if you start getting close to 70%, 80% or something like that, you might want to spread your applications across more file systems. With throughput, the throughput of your file system depends on how much data that you're storing in it if you are in bursting mode. So throughput mode of bursting means throughput's based on amount of data. Alternatively, I could have throughput mode of provisioned. And you might want to switch between those if you have a high throughput application that is operating on a small amount of data that doesn't entitle that file system to that amount of throughput. And the way that you can tell is, again, by monitoring this metric. So I'll show what it looks like to configure provision throughput. There we go. I'll just go to provisioned, and then I can just type the amount that I want. Now you'll see here, a few months ago, we decoupled the amount of read throughput from write throughput. It used to be that you would configure 1 GB per second, and you could either read or write against that. Now, if I configure, let's say, 100 megabytes per second, we'll actually let you read up to 300 megabytes per second, because what we're doing is we are discounting your reads by a factor of 3. So if you're doing 300 megabytes per second, we are going to meter it as if it's 100 megabytes per second of write. So your actual throughput on your file system is 100 megabytes per second, but the more reads you're doing, the higher you can go. So that's kind of cool. But again, keep an eye on these metrics on the back end. In often cases, bursting mode is fine, either if you don't have a lot of I/O or if you have a lot of data. But again, monitor it.
And with the addition of provisioned throughput, I suppose that also opened up for a lot more use cases using EFS. I mean, you know a lot more about this than I do, but previously there were use cases where you perhaps had so small amounts of data that it was hard to use EFS because of the way that the bursting throughput works.
Right. Yeah. And in the olden days, before we introduced provision throughput, what a lot of customers ended up doing was adding padding data to their file system in order to entitle them to a higher amount of throughput. Right. So with provision throughput, we simplified that process and took away the need to do that.
That's cool. And the monitoring you're seeing here, that is available in CloudWatch as well. So you are able to set up alerts on that monitoring as well.
That's right. Yeah. So let's just get back in here. Anything you see in our monitoring tab, all we're doing is showing CloudWatch metrics. So you can just click to see more in CloudWatch, or you can, for each one of these, view it over here and set up your alerts, just like you said.
Right. Cool. So when we talked about access points, that relates, of course, to security as well with the users and the groups. But we also have IAM. How can we use that as an additional way to then restrict access or gain access to?
I was hoping you would ask. So like you say, so we have these access points, and these access points are related to security. But what many people like you would have been wondering is, how do I make sure that my application chooses the right access point, or they don't choose an access point that doesn't have the right permissions? So there has to be this mapping between IAM and access points, kind of to bridge between these two security domains. And the way that you would do that is with IAM. So we see here that we have this file system policy tab. Now, by default, your policy is going to be null. And a null policy means this file system is acting like an old school file system that doesn't have IAM on it at all. So it's going to allow any applications with network level permissions to mount it, but it's not doing any additional enforcement. But I can change that by clicking on edit. And then we have this policy editor here, and then we have a couple of common things that customers want to do that we can put in here. So one is I can prevent root access by default. So if I know that I, under no circumstances, want anyone to mount as root, I'll click that, and it's going to create this policy. And in this policy, you'll see how some of this stuff works. So this is a resource policy. So this is something that sits on the file system. You can use these same actions from identity policies as well if you want to come from the other side. But we have these three actions set up. So we have an action called client mount. This entitles an application based on IAM to mount the file system, but only read it. If I want that application to also be able to write anything, then I would add this client write. And there is also a client root access permission that is not being given when I click this. And that's how we prevent any root access from coming in. We could make it read only by default. So now I have root access and mount, but it's only read. And do both of these together, and now it's only mount. So I'll just walk through the other ones, and then we'll get to the point about access points. So one thing customers often want to do is make sure that all of their connections are encrypted. So with EFS, you can, from the client side, choose to either encrypt or not encrypt via TLS your NFS connection. But since it's a client-side action, you may want a server-side way of making sure that your users are checking that. Now, with Lambda and containers and things like that, we turn encryption on by default. But for EC2 instances, you have the choice. So what we can say here is we have this condition key for AWS Secure Transport. So this says deny in case this condition is false. And that's how we control that. And this is a good segue for how you would write a policy that ties an IAM role to an access point. So the way that works is we use condition keys. So imagine here that I have a statement that says action, maybe I don't want root access, but I want read and write. So that's fine, access via mount target. Now, actually, I'll just paste this up here. Sorry, one sec. So we have a condition key for specifying what access point that you have. So EFS access point ARN, and then I would put my access point ID. And this basically says that any principal now has access to that, or if I tie this to a specific principal, now that principal can mount and write, but only if it's encrypted and only if it's using this access point ID. So if I have a multi-line policy, that's how I can tie this IAM role is this access point, this IAM role is this access point, and that's how I can establish that relationship.
All right, really cool. So Will, we're approaching top of the hour. 3-4 minutes to go. So
it does fly by.
Yeah, it does. So do you have any quick best practices to share with us before we wrap things up?
Yeah, so the things that I wanted to call out were, of course, make sure you're monitoring your file system. We talked about the throughput stuff. The two additional things that I would call out and recommend, one is, now it's showing up, lifecycle policy. So this, by default, when you create your file systems, we will turn on a feature called lifecycle management, which means any files that you haven't read or written for 30 days are going to go into infrequent access storage, which is 92% lower cost than EFS standards. So by leaving this on or even making this a more aggressive policy, you can save considerable money on the files that you aren't reading or writing frequently, while still having access to that data if you ever need it. It's still, if you LS or do a read, all of that data is still there. It's just you're paying a lot less for it. So for those of you that are cost conscious, this is a great way of saving cost. And the last thing is backups. None of us want to be in a situation where an application accidentally deletes a file that another one needs or something like that. And it's really easy to prevent by either configuring AWS backup directly, or in this case, we automatically back up your file systems. So when you create file systems using the easy path, we will set up the backup policy in the back end. We will make all this happen. So if I ever did accidentally delete some data, I could just surf over to the backup console and start setting up a restore. So recommend both of those. Cool.
All right, everyone. That's the hour. So if you just joined us now, well, too bad. You just missed 1 hour of modern application development with persistent storage. Will has talked us through that with Amazon EFS. But don't worry, this entire episode will be available on demand. Of course, you can just rewatch it. So thanks a lot, Will, for joining us today. I know it's early for you.
No problem. Pleasure being here.
Yeah, and for everyone watching, thanks a lot for joining us. Next week, I'll be joined by Alexander Dragunov to talk about CDK, which is an exciting topic. So with that, I want to thank you all very much, and hopefully I'll see you next week. Bye-bye.